This is Mr. S, your friendly local neighborhood technology and engineering teacher. We're going to follow up on how we created our top view now with taking a look at how to create the side view of this solar car. Okay, so what I'm going to do is I'm going to go ahead and I'm going to pull up our ladybug so that you can see the paper. And then we'll just make sure that we have our audio all the way up. That way we can go ahead and start. So we did our top view where we had our kind of x-ray vision. And that's going to tell us a lot about the mechanical stuff of the car, but it's not going to tell us necessarily about what the car's shape or theme looks like. And that's where the side view is going to come in and become more important. If you look, we have our side view here, and really that's kind of what the car presents itself as to people when they view it. So the side view is a lot more important for getting an idea of what the shape or the theme of your car is. So we're going to continue with the same model, taking a look at what we had already drawn, and we started, of course, with the border, because unfortunately, our side view did not fit on the same side of the sheet, so we had to flip it over. So if you remember, this car here was 9 inches long. We had that measurement on the top view. However, the top view only told us how wide this car was, not how tall or any components of the shape. So right here I see that we have a 3 1/4 inch tall height to the top of that box that's covering our motor and battery pack. And then if I were to take my ruler and actually measure this sidewall, I see that this wall combined with the base is about 2 inches high. So before we do anything on this side view, we're going to start by drawing the general outline of this shape, which is right here. Okay, so we have a 2-inch rectangle, a 3 1/4 inch rectangle, and combined we have a 3-inch length and a 6-inch wall. So what we're going to do is we're going to measure 3 1/4 up, and we're also going to measure 2 up. And we're going to make our marks to draw that shape. So you'll see now I've created sort of this L shape here, which looks really kind of simplistic. But if we actually look at the side view of our actual car, that's what we're looking at. We have this block here, which is indicated here on the drawing, and this block here, which is indicated here on the drawing. Of course, there's some other details that we now need to add. For example, we're going to need to add our windshield extending upwards, as well as the support piece. So that's going to give us a triangular view from the side. From the side, what we see here is this shape is a triangle. Even though that triangle is made out of air, the outlines of those indicate where they'll be placed and how tall they are. Of course, we are also going to need to indicate where we're going to be placing this solar panel. The side view is going to tell me how tall that solar panel holder is, whereas when I look at the top view, that's going to tell me where I am gluing that. Just like something to keep in mind, we're looking at a sample car, which just means that not everything about it is going to be perfect. For example, if I look at this solar panel design, that's actually quite tall. If I look at it, it doesn't really need to be that tall to clear anything. So that's something you want to consider when you design. We're drawing this based off of a model. That doesn't mean your design is going to be based off of this model. So what we're going to do now is we're going to draw this right here. We're going to take a measurement. I know that this goes 2 inches in, and the line is 2.5 inches tall. And then this object here, this support, goes 3 5/8 inches and 3 3/4. And that object is going to be 2.5. So 3 3/4 and 2 inches is going to be my maximum height. And then we'll take care of that after we do the windshield. So what you see here is you'll see some eraser markings. I've been kind of cleaning this up as I go along. When you finish, of course, you're going to go back and erase what you don't need and also darken what you want me to see. But we see now that we have this triangle here. We've just drawn this here, and the way I did that was I made a mark at 2 inches in. That's where this line stops. And then I measured the 2 inches up that it goes. And then I just kind of freehand connected my dots to my measurement points. So again, this is going to be a little more challenging for you because I'm measuring off an existing object. All these measurements are going to be coming from your mind. The next and final thing that we really have to figure out is how tall this is going to be. And just keep in mind that as you're doing this, the top of this line right here is 2 inches in. That should match up with your top view. The same is going to be true of how far in the solar panel is. If the solar panel is, let's say, 2 inches from the back edge on the top view, when we draw this, we want to draw it 2 inches in. Otherwise, when I go to build, I'm not going to know what those proper measurements are. So we want to draw our solar panel holder. On this design, it has this particular screw on it that lets it adjust. Now, not all cars will have adjustable solar panels. For example, if you had a fixed angle solar panel, you may just sit your solar panel right here on this angle. And if that is how you do it, then you wouldn't need to draw anything else because your solar panel's sitting there. I don't need to see you draw a solar panel for me because you're not going to be building that. You're just going to be attaching it to the pieces that you did build. For this particular design, because it has an adjustable solar panel, we need to know how big we're going to cut those pieces. The total height of this assembly is 3 3/4 inches, with one of those pieces measuring in at 2 inches and another one measuring at 1 3/4 inches. If I actually look at this, even though from the front I see that it's 2 pieces, from the side, all I really see is the total rectangular height of the device, and that's 3 3/4 inches by 3/4 of an inch. On the top view, it tells me how far from the edge, but looking at 2D from the side, I have no idea, so I'm just going to draw it right in here. How far in I will draw it is dependent on how far in it goes. It starts 2 1/4 inches from the back, 2 1/4 from the back. So we're going to go 2 1/4 inches, and then we're going to draw our 3/4 by 3 3/4 inch tall assembly. So you'll see I've drawn the rectangle to represent the vertical height of this assembly. And I also need to indicate that it actually has a tray on top. I believe that we measured this. We drew this on the top view. It is 2 3/4 or so. I believe we had drawn it as 3 by 3. Yeah, so we need to indicate that we have a 3-inch tray up here. We're going to use the number 3 just to match our top view. Okay, so we would draw this, and this actually has a thickness of 3/16, so it would not just be a line, it would be 3/16 by 3. In fact, when you look at all of these, in reality, this is probably going to be a piece where I would draw the thickness very neatly. But to simplify things right now, you could always go back and draw the thicknesses in. Right now, we just want to focus on getting the primary shape out there. So I'm going to draw on this tray. So we're approaching being done with this drawing now. If you look, I have drawn this tray here with the thickness, and there's a few details that I've included. I put an X here. That's just to indicate to the person reading this drawing what the location of the screw is going to be in the assembly. What I've also done is, even though I can't see it necessarily, depending on what side you look at, I've also drawn a line indicating where the break in these 2 pieces in the assembly are. And I've put my tray on there just to indicate that it's a regular piece. At this point in time, if you look at the 2 cars, believe it or not, so actually what we're going to do to make this a little easier, we're going to slide this drawing down. We have our object here. Okay, there's our drawing there. In reality, if everything's drawn properly, it should match up pretty much on top of it, which it does for the most part. The final thing we'll have to do is the wheels. If you recall our bearing lines, the rear bearing was 1 inch in. The front bearing was a 1/2 inch in, so we'll make a mark. And if we really wanted to cheat on that, we could simply put the center of our wheel right where our bearing lines are, and we could trace. Of course, you could use a circle template or a compass. But again, the wheels, I'm not so much concerned, and no one who is looking at this would be so much concerned about seeing a beautiful, perfect wheel, because you are not building the wheels. So that's how I would do that. If I had a different size back wheel, I could pull that wheel off and trace. And you could always go back. You could always improve things. You could always add labels, details, and colors to this. But right now, fundamentally, you have all the information you need on this drawing to cut and assemble the pieces. The last thing you would do is the front view. We may not have a video for that. You may want to try to synthesize what you have from your side view and your top view, and it's going to make your life a lot easier when you draw the front view. Once you have all this done and you have all this, make sure that they match. Your top view matches your side view. That way there's no discrepancy. All the pieces are the same size. Building really shouldn't be that challenging because you're just following a set of plans and directions you made up for yourself.